Hello once again, it's tubalcain, your YouTube shop teacher. Welcome back to my humble shop. Today I am embarking on a rather ambitious project, if you will. Perhaps a 3, maybe even 4-part video series on cutting and making rack and pinion. Much smaller than what you see here because my machinery is limited, and I've made some other videos on gears and gear cutting over the years, so I'll show you a list of those in a minute. But the subject of this first video will be cutting a rack. Now a rack is nothing more than a linear gear or a straight gear. That's all it is. Let's get started. Pause your video to read this if necessary, but here's the 6 other videos I've made over the years on gears or gear cutting. Not everything will be covered in this video in regards to gear geometry and all that. That's in these previous videos. This is a small Arbor press that we made in the machine shop class, and it's one of the Peterson Products projects. And this is aluminum, which really makes it worthless as far as having any pressure or usefulness, but I think there were a lot of operations that the kids learned on this. I do not own this. I borrowed it from a friend. I didn't know that he still had one of these. I must have given it to him many years ago, but you can see there's still some of my writing with a magic marker on there where I would have been instructing a student on, making some holes or whatever it was. I don't remember. This rack is 7/8 square. So I know it's one of the later ones we made because earlier we're making 1-inch square, and this was based, that's a 9-inch long rack. The entire Arbor press here, and especially the length of the rack, was based on what we were able to do in the school shop, and that means that our Greaves milling machine, did you ever hear of a Greaves milling machine? It was one heck of a good horizontal mill, but that was the maximum length of a rack that we could cut on that machine, and I'll explain that a little bit later on. And it was still difficult for the kids to do because we had to move the cutter on the Arbor at least once, maybe twice, and lining that up with the piece that they were cutting was no easy job. Many of them spoiled the work because then they would end up with one fat tooth and one skinny tooth, and that doesn't work. This is the original blueprint for the Arbor press that was sold to the schools. Now notice the rack. The reason I'm showing you this here, there's the rack, much larger than what I'm going to do today, but from the drawing here you can see that the kids did not need a whole lot of related information because there in the notes it tells them to make a 12 diametral pitch gear, 14.5 degree pressure angle, which is cutter number 1, that's hard to read, a linear pitch of 0.262 I think it says, and the tooth depth. That's all they really needed to know when they went to work on this. Although I did present some of this related information, but probably to deaf ears. The term rack and pinion is used very often, and every one of you have used a rack and pinion within the last day if you drove your car, because virtually all front-wheel drive cars have rack and pinion steering, but hardly anybody really knows what that means. But here is the rack that I'm going to make, much smaller in length and a smaller pitch because those are the cutters that I have in stock. Now the pinion is a gear. I have not made one yet. This I made during rehearsal to see if this video series was viable. And then in the 3rd part or 4th part, I'm not sure which, I will just take this block of aluminum, bore a hole in there for the pinion and a slot so that you can see the actual rack and pinion work and how they're mated together and how they mesh and all of that good stuff. So in other words, I'll be making a do-nothing machine, really just composed of this end here, the rack, the pinion, and the block of aluminum I just showed you with a cover plate. That's all we're going to do, but it's no small job. And why did I choose this size and 20 diametral pitch? Because I have a set of them from another job. It might be in those other videos, I'm not sure. And here is the set, and there's always 8 in a set. Actually, there would be 15 in a complete set. I'll talk about that later. Now, these, I'm not sure where these were made, but I know it wasn't Providence, Rhode Island. But there I wrote the tooth depth some time ago, and let's see, I bought these 5 years ago, and they are 5/8 bore. So that's why I had to make my own arbors. They have a tiny hole in them compared to most other, like this one, has a 7/8. So 7/8 and 1 inch are the most common. So that necessitated a special arbor. So I've already spent 2 hours making that. So you can see there's a set of 7. The 8th one is already in the machine installed, but most gear cutters are relatively small diameter. And I don't know why we got 2 different diameters here within this set alone, but typically they're around 2 inches. That alone causes there to be a problem sometimes with setting it up, clearance problems. It would be nice if these were 4 inches in diameter, but they tend to be small, all the ones that I have ever seen. Now, where can you get information on gear cutting and gear sizes and all of that information that you need? Well, any machine shop book such as this has a section on it, as does Machinery Handbook. And you know, the little black book here has just 2 or 3 pages, but it's so concise of what you need. You don't need 20 pages or 30 pages like some of these books. That'll only confuse you. There's some information in here I'm going to show you in a moment. But here's a book that I've had for several years called Gear Cutting Practice, and that has also a lot of information, but really more than you need. Some of it is engineering, and it's way beyond me. This is the old Brown and Sharp book from 1941, telling cutters 1 through 8 and what number of teeth that they will actually cut. So I'm really using cutter number 1 already set up in the milling machine, and later on I will be using cutter number 6. Now that's what you're going to find now, and you usually have to buy a whole set like that, so that's why it gets to be expensive. But enlarging that just a little bit, some of these cutters cover quite a range of teeth, so it's a compromise. So I don't think you can get these anymore, but see, there's 7 more here. For instance, cutter number 1.5 covers some of the other teeth right here, because when you get into a rack, the teeth are almost straight. There's no curve to them. Perhaps you can tell this by looking at this. You see what I mean? I don't have a gear to show you right now. That alone is probably more than you need to know, but and you'll never see these anymore. I'm just showing that for your information. And here are all 15 cutters in chronological order, and that constitutes a complete set of 15. I do not have a gear gauge. However, I do have several books that show the profile to the actual size. For instance, this is a number 2 pitch, and you can work your way down. The one on the Peterson Products Arbor Press was a 16, which would be that one. And I'll be dealing today with 20 pitch, which is the smallest that they show you on this page. And of course, these are involute spur gears, S-P-U-R, the simplest type of gear. There are many, many other kinds of gears. These are spur gears. In the wonderful little black book, there's a couple pages facing each other here with some diagrams and all of the formulas or information that one needs for cutting gears. You really don't need a whole lot more than this, but this is available in any of those books that I've shown you, and probably on the internet as well. Here is a nice sketch of a rack and pinion engaged and some of the terminology, and notice the different shape here between the teeth on a rack, which are almost straight, and the more curved teeth on the pinion, and that is why cutting gears requires a complete set of gear cutters. Now there's really only two dimensions that we need to know in order to cut this rack. One is the depth of the cut, or the depth of the tooth, and the other is the distance between the teeth. Now, circular pitch on a gear is the distance from the center of one tooth to the next tooth. That's circular pitch. But when we translate that into a rack, circular pitch in fact equals linear pitch. So I'm interested in linear pitch, but first of all, let's look at this. And I took this right out of that black book. Tooth depth for a 14.5 degree pressure angle gear or rack. The formula is 2.157 divided by the pitch. Now 2.157 is a constant. So carrying that out, and the pitch or dimetral pitch is 20. So doing the simple division there, we find that the depth of the tooth is 108.108 on both the gear and on the rack. And then we must find the linear pitch, and remember, circular pitch equals linear pitch, but the formula for circular pitch is pi over the pitch, which is pi over 20, and doing the simple division with your calculator, the pitch is 0.157, or a 157 thousandths from tooth to tooth. I'm going to cut this rack on the Bridgeport mill rather than a horizontal mill, and a horizontal mill is preferable if you have a large enough one, but with my setup here, which you might find a little different than what you normally see, you can tell that I'm using the right angle head. And by the way, that was given to me by Ron Cox, the same wonderful man that gave me the South Bend shaper. But anyway, this is the setup. And there are really three reasons why I do not want to do this at this time on my little closing horizontal mill. Let me explain that. I'm fully aware that this is a terrible picture. I just took it off of the internet, off of YouTube, but this is to show a man cutting a rack, and that if the rack has any length to it at all, there's going to be interference here, where this end of the rack strikes the support, or this end of the rack comes all the way up against the arbor at the other end. So, and the diameter of the cutters, as I explained, is so small that causes there to be interference here. There's just no distance at all. That's one of the problems of doing it on a horizontal mill. Although I hope to show that, but it's often you have to move the cutter several times. And the other two reasons that I am not cutting this rack on the closing mill out in the garage, number one, is because it's 10 degrees out there, and number two, I do not have an arbor that will hold these smaller cutters with a 5/8 bore. Now there is the possibility in the future that I make an arbor and the weather warms up and I can get out there and do it on the horizontal mill, but I'm not sure at this time. This picture is out of the wonderful book by Cincinnati Milling Machine entitled Treatise on the Milling Machine, and the picture is showing a rack cutting attachment on a relatively large mill, but it's cutting the rack teeth at an angle on this particular one. Now, I just explained a bunch of problems and how difficult it is to actually cut a rack. Now, because of that, very few people cut racks, at least in their home shop or even in industry. What they do is they go right to the McMaster-Carr catalog, to the correct page, and McMaster-Carr sells, for instance, in this size, a 20 pitch, you can buy a 2-foot piece for $28. Of course, there'd be another $50 postage and handling, but that is the way you would do it. And they're available in different pitches and different materials, I think including plastics. So a lot of people get around it by just purchasing a length of rack. But we're going to do it anyway. And what am I going to use for material? Well, I'm going to scout around here a little bit more, but this was simply made out of a used piece of key stock. It had a hole drilled in it and so on, and this is 1/2-inch key stock available at any hardware store, and you get that in different sizes. Alright, let's get over to the milling machine and get ready to actually make some chips. Alright, let's take a look at the setup now. Again, the right angle drive, and there's the correct cutter for cutting racks. Now I had to make this arbor. I had to make it first of all so it would fit in the collet, and I'm using a 3/4 collet, R8 collet in there. And this is 1¼ inch in diameter, and I mounted this out near the end, and then a collar and then a nut, and the cutter is keyed onto the shaft. Remember, it's a 3/8 shaft, and that's why I had to make this thing. Now, yes, I know that the first thing you're going to say is this is outrageous. This is way too much distance here, unsupported. And I know it is. I'm fully aware of that. But otherwise, I couldn't do the video. And it does work. And I did not have any chatter, but there isn't much of a depth of cut. But if you had a greater depth of cut or, larger tooth or harder material, take several passes. But I'm going to take it all in one pass. So that is the setup. And if you look right here, I always write down critical dimensions. So again, 108 deep, 0.157 linear pitch, and the RPM is 135. I could go a little faster than that, but I do not want a chance ruining the cutter, because I only get one chance at this. And make sure that you do not run your cutters in reverse, or you will ruin them within 1 minute or less. The work is held on parallels. That is a piece of 1/2-inch stock that I finally found around here. I spent a half hour looking. That's the longest piece I could find. It's a little rusty, but that isn't going to hurt a thing. Now, let me unlock the table here and move it down, and you can see the reach that I have without striking this. So I can cut about 4 inches of rack with this setup. Otherwise, I'd have to have this longer, and I thought about different ways of supporting the end, and there just is no practical way of doing it on this machine with this setup, because I spent enough time just making that arbor, and I probably will have to make a shorter arbor when I make the pinion in the next video. The right angle drive has to be set perfectly perpendicular or square or parallel, whatever you want to call it. So I put the indicator on the table here with the probe up against this true surface and ran it back and forth until I got it on true 0, and then tightened these 2 bolts securely. I'm going to show you how I move the table right now, because I'm not going to show that during the actual cutting, because I don't have 2 cameras and I don't know how to cut in that extra footage. But with it on 0, I'll cut my first tooth, and then I can move it up to 157, which is the linear pitch. Right there. I could cut that tooth and then 0 it out and do that again. However, there is some error introduced by that method, so I had my wife make up a chart for me, and for each tooth there is a coordinate or a number. In other words, tooth 1 is, would be actually 0, and then 157, we add another 57, 157, and so on. And she did it for me, thank you Jeanette, all the way up to 30 teeth. I don't think I'll go that far, but she did the math and she did the typing, because she's mighty good at that and willing. So that's how I'm going to move it from tooth to tooth. And I taped that chart right onto the digital readout. Now, if you do not have a digital readout, you could use just the dials, because after all, that's how we did it in the high school, and it was pretty satisfactory. And you could also use an indicator to move between teeth. This is the preferred method, the easier method. I am fully aware that that was a terribly long introduction, but all of that related information really is necessary to know before you start cutting a gear or a rack. But let's finally make some chips here. I did find a better piece of 1/2-inch square stock, so I have that in the vise now, tightened down on parallels. Notice that, I don't know if I got the right camera angle here, but this is the maximum length that I can cut without the work hitting the angle head here. So the first thing I'm doing is to put some tape on here, and I'm going to touch off and then raise the table, raise the knee to the correct tooth depth, which is 0.108 inches. Be sure and wear safety glasses and observe all the safety rules when you work on machinery. Alright, let's turn the machine on at 135 RPM. Make sure you go the right direction so you don't ruin the cutter. Alright, I've touched off, and you can see the hole in the tape, I think. Now I will back off and raise the knee 108 thousandths. Okay, and I will lock the knee, and that will remain constant throughout the job. Alright, let's cut. Several things. First of all, the Bridgeport sounds much louder on video than what it does here in real life. Also, there are some times that the cutter will be appearing to run backwards, but that's the wagon wheel effect. And thirdly, I will be speeding some of this up to reduce the time and the boredom. Just about done. I just have 2 more teeth to go. And there it is. A successful rack. It looks pretty good. I'll take a closer look, make sure I don't have any fat teeth and then skinny teeth, which I know I do not, but you got to be careful when you do this. Alright, let's take it out. Alright, I'll clean it up. Let's go over to the bench. Okay, the gear teeth look real good. I have to deburr just a little bit with a file and so on, break the corners and clean it up again. Get the lint out of there. I know you think I own every Starrett tool ever manufactured, but I do not. Here is a 456 gear tooth vernier caliper that would allow the inspection department to check gears for actual size according to the blueprints or the dimensions given or specifications, but that's a little bit overkill for what I'm doing here because mine is going to be strictly a visual check, and then once I get the gear, the pinion made, the truth will come to light when I run it across the gear. But I'm quite sure that this will be okay because I used a digital readout. And I worked very slowly, carefully, and methodically. This is the Arbor that I made especially for this job. This is 3/4 inch, 1 1/4, and 5/8 diameter right here to accommodate the cutter. And it worked quite well. Well, that completes this lesson, this video on cutting a rack on the vertical milling machine. Be sure and stay tuned and watch the next video where I do essentially the same job on the closing horizontal mill, which will require me to make a separate arbor for this job. Thanks for watching, and I'll see you next time. This is tubalcain.